Our next guest is leading the charge in developing high-intensity electrical engines for aircrafts. Magnix, a subsidiary of Heron Energy, being backed by the Australian government, receiving a $2.5 million grant earlier this year. Joining us for more on the work being done in the space is Managing Director of Magnix, Dr. Jason Chaffey. Dr. Chaffey, appreciate your time today. Electrical engines, common in cars now pretty much, but not planes. Why?
Hi, James. Well, fundamentally, what is required for electric aircraft is a high power density electric motor. And what we see today in cars and other automobiles are electric motors that are a lot lower in their power density. But for aircraft, fundamentally, they need to be a lot lower in mass and size to make it viable for electric aircraft to happen.
So what is the technology then that you're developing, that you're utilising?
Yeah, so with this technology, we're developing a high power density electric motor that is specifically aimed for the electric aircraft industry. And the motor itself is fundamentally different to how other electric motors operate today. That is in the materials that are being used to reduce the mass and the size of the electric motor, but also fundamentally the way in which we use the magnetic force inside the motor to reduce the overall weight, but also increase the power density of the motor. And this is what's really needed for electric aircraft to be viable.
So light and fast.
That's right.
I know you're working on a prototype. How advanced is the prototype motor?
Well, where we are today is that we're literally weeks away from testing our first prototype, which will be a 5 kilowatt per kilogram motor. And I hope to be back here soon with you, James, to talk about how that prototype and its testing goes. We're also working with the University of Queensland and Ferrer Engineering in Queensland. 3 companies are cooperating to work on how we move past this motor that we're developing today. And each of the companies are located within 50 kilometres of one another in southeast Queensland. So we see this as an excellent opportunity to be working with local companies based here in Queensland.
So getting the weight as well as the speed, obviously crucial, but what about charging as well? I mean, is that something else that you sort of need to look at as well? The fact that a lot of people take long-haul flights. I'm not suggesting you're going to be doing Sydney to London or anything like that anytime soon, but is that another one of the stumbling blocks when it comes to these sorts of engines, these sorts of motors?
That's right, James. And what we see is that innovation typically occurs in smaller aircraft first, and that's where we're focused now with our first motor that we're developing for electric aircraft. From that, we then expect to be able to expand that and build upon the project that we're using today and the outcomes of that project to develop a motor that is much larger in power density and is suitable for commercial aircraft. So today we see small electric aircraft being possible, and then in the future, in the next 10 to 15 years, we hope that our technology will be at the forefront of commercial aircraft.
We made mention in the introduction some funding from the Australian government. How much more cost is involved, if you like, to get it not just to the next level, but getting something to market?
So what we see with the federal government funding and the project is it's a $12 million project over 3 years. And beyond that, what is required is significant more investment in the testing and reliability. As you can appreciate, the aircraft industry is conservative, and there needs to be a lot of testing and reliability done before these motors can be used in electric aircraft. So what we see going past the next 3 years is another round of funding to develop the solution further.
And in terms of the potential size of the market when it comes to electric motors, powering aircraft, I mean, how big a market is this potentially?
It's quite significant, James. What we see is that every 15 years the number of aircraft are doubling in the world, and so we expect to see more aircraft in the skies as we go into the future. And furthermore, Australia and New Zealand, it's a little known fact, have the highest number of aircraft to population ratio. So we see this as an excellent opportunity to prove this out here in our own backyard and work with local companies to demonstrate this.
Does it also fit into an increasingly carbon-intensive sort of environment that we're ever moving into?
That's correct. every year, the fuel that's being consumed is $246 billion worth of fuel that is consumed every year globally to fuel aircraft. And so that's a significant number. And I think airline industry is particularly interested in reducing this figure, and certainly that's going forward. But just apart from the fuel cost, there's also the impact on the environment, and we see that that is a significant impact of what we're developing with our electric motor. But if we look at the airline industry alone, it contributes something like 10% of all greenhouse emissions globally. And if you look then at aircraft themselves, they contribute more carbon per mile per passenger than any other form of travel. And so having an electric aircraft will certainly help the environment considerably.
The benefits, as you've laid out, are pretty obvious then in terms of getting something like this to market. I suspect then that there must be competition, other organisations also working on trying to get some sort of an electric motor to market.
That's right, and the market at the moment is an emerging market. There's a number of players in this space. NASA with the X-57 program to develop a research electric aircraft. Airbus are working in this space, and so is Boeing. These companies are all looking at the small end of the market and initially to prove out their technologies, and that's where we're focused with our own developments of our technology for this part of the market as well.
All right, Dr. Chaffey, got to leave it there, but you're right, we'll have to get you back on after the testing. Thank you.
Okay, great. Thanks, James.